because again, as I think obviously Simon mentioned, one of the fuel for the IT industry or the high-tech industry is really the people that are coming from this intelligent group. And once we have that pool of talent, then the rest of the industry starts to scale. And the fact that we reached that point is a big milestone in my view, and going to change a lot of the things that we've seen so far. So thank you very much for coming here. I know it wasn't easy, and for collaborating and sharing all these beautiful slides and content. With that, I'd like to invite Jesse. Where is Jesse? Oh, there you are. So this is your first time here? First time here, excellent. So those who don't know Jesse, me and him had some interesting dialogues on panels in the past couple of years, so I'm happy to have you here, having your own talk without us arguing and stuff. So Jesse has been part of actually a big transformation in IBM with Bluebox and so forth, and he'll talk to us about it, but I think also as an entrepreneur, I'd be very happy to hear about your personal experience during that. So thank you very much and for coming here, and I look forward for the talk.
Thanks so much. Do I need to swap the slides? I can talk to the IDI slides, but it'd be a terrible presentation. So I'm Jesse Proudman. I'm the founder of Bluebox, which actually a year ago to the day was acquired by IBM. So this is our 1-year anniversary. Here we go. Super tech support. Perfect. Thank you. So yeah, a year ago we were acquired to the day by IBM. So I'm 1 year into Big Blue. I'm here to talk about hyperscale computing. And I think we live in this world, particularly in the OpenStack space or in cloud in general, where as new technologies emerge, everybody has this desire to adapt and adopt whatever is on the bleeding edge. And I think while that's exciting, can often be a challenge for most people on that bleeding edge, and let alone sort of the enterprise user. So I wanted to kind of talk about what is hyperscale, how it applies to what you're doing today in your organizations, and then how it doesn't apply, and then finally, what are the lessons you can learn from these technologies. So we'll start with hyperscale as a definition. Hyperscale in the cloud world, in my mind, is really about incredibly large installations, like unthinkably large installations of cloud infrastructure. These infrastructures support cloud-native applications. They're entirely automated. It's commodity everything. So we're not talking about sort of your legacy enterprise data center. We're not talking about sort of your telecom closet. We're talking about things in the world that Google, Microsoft, IBM, Amazon, that these companies are doing. And so I like to kind of start and go through some of these photos. So on the left here, this is Google's data center. On the right, we've got Facebook's data center. They actually built a new facility close to where I live in Seattle, and they engineered the entire thing from the ground up with custom racks, custom cooling, custom hardware. This is one of their chips. Obviously, Open Compute is a big part of what Facebook's doing. Here's Microsoft. Microsoft was like, hey, we're doing this cloud thing, and data centers are cool, but we're going to put one in the ocean because it's not enough of a challenge to just do it on land. So who has a data center here in the ocean? IDI might, but they're not going to talk about it. This is IBM. So IBM just announced a quantum computing environment that you can go get access to do development work. Like quantum compute, Tim Bell might be able to beat this with his keynote, but quantum computing is like on the bleeding edge. We've got 40 data centers around the globe, like that scale. When we were Bluebox, we had 4, so to go from 4 to 40, much different experience. Cyberscale is not sort of your traditional data center environment. And actually, as I was going through this presentation, I found these photos. This is from the Bluebox data center from like 2005. I did all this wiring myself, which was basically like a mat of cables behind these servers. But this is not what we're talking about. We're talking about a very different type of environment. We're talking about something much, much larger. And so the question is, why does it matter? Like, who cares about these big environments, and how does that relate to what we're doing with OpenStack, and how does it relate to what everybody here is working on? And so, as Jonathan likes to say, the future is software defined. If you look at what everybody in this room is trying to do, we're all trying to deliver solutions to our customers, whether it be an end user in your organization or to your actual customer itself. And all of those solutions are built by software that you're either consuming as a service or you're writing in your enterprise. That software runs on a platform, that platform runs on infrastructure. So if we think about that paradigm, the key part there is the software and the solution that you're actually delivering. The infrastructure piece, at the end of the day, is irrelevant. It's just the foundational technology that is there to support that solution. So the challenge is that software does run on hardware. That hardware, while at the end of the day we don't want to think about it, it is important. It's important because somebody has to deal with it. And that somebody is likely one of you in the room. And the reality is that that cloud thing that was supposed to take the idea of dealing with hardware away from day-to-day operations, like, it doesn't. There still is hardware, and it's somebody's problem to deal with. You think about everything that Amazon, Google's, IBM, like everything that they're doing, there's hardware sitting in a data center somewhere, and it's the same type of hardware, and it's mildly different than it was 5 years ago, but it's still in a data center. There's still the guy with the beard walking through the aisles, plugging cables in. Like, nothing there has really changed. And so what are the lessons that we can learn as we think about adopting what those large-scale providers, the hyperscale providers, have done into what your enterprise is doing? So let's look at the reality of public versus private cloud. So public clouds, and we're basically 10 years or so in. Amazon started in 2006. So 10 years. Public clouds now really are focused on this notion of standardized hardware. This differs from private clouds and traditional enterprise environments where you might have one of everything. I met with the CIO of an insurance company in Seattle, and he literally said, my biggest challenge is that if you name a piece of hardware, I have it in my data center. Like, I have one of literally everything, and I've got to figure out how to deal with that. So we don't have that problem in public clouds. It's all new hardware. It's all standardized. Most of it's white box or ODM, manufactured for those vendors. As that equipment dies, it's left for dead. Nobody goes in and tries to nurse it back to health or fix it. And these companies are achieving high availability in software, not in hardware. So if we think about, like, IBM is a great example. If you think about traditional mainframes, and we had one of these, we had a mainframe at our booth in OpenStack Summit, you have so much built into the hardware for that high availability that the machine itself is very resilient. We don't worry about that in the world of cloud. Like, the world of cloud, you build that layer in at the software stack, at the application layer. So then we think about public cloud and we compare that to enterprise data centers or new private clouds, and we've got that problem of one of everything. You may have mainframes. You might have you have COBOL running something. You've got Windows. You've got VMware. You've got Linux. You've got this whole host of infrastructure, and a lot of it's proprietary or unique. When those things fail, you've got to get them back up and running, and you've got to figure out what the part is. And so you need a medic when your server gets sick, and that high availability often is delivered through hardware. You know, when I started Bluebox 12 years ago, we were doing load balancing, and we had hardware load balancers, right? And they were in HA pairs, and you had to make sure that when one failed, the other one would take over, because that was the kind of the lifeline for the infrastructure. And today, when we talk about load balancing, it's all done using software load balancing implementation, so you don't worry about that hardware. So how do we blend those hyperscale lessons that those public cloud providers have learned into what we're doing in the enterprise today, even though we're not operating at that same scale? Well, the first is to think about the software itself. So from a Bluebox perspective, if we back up to 2006, Bluebox was a managed hosting company before OpenStack was around. So from 2006 on, we were doing essentially Ruby on Rails managed hosting, similar to what Rackspace was doing, just focused on Ruby on Rails. And we built our own cloud technology. We had engineers in-house. We wrote the whole thing. My poor engineers had to deal with code I wrote. I feel bad for them to this day because it's still running to some extent. But we wrote it from the ground up. And ironically, it was using containers at the time in '06, so I totally missed that wave. But we realized as we got through that process, as OpenStack came out, we started to track the technology, and we realized we can't keep up. Like, there's just no way to keep up with the velocity, the rate of change that the industry is going through on our own set of technology, let alone to match or mimic what OpenStack's doing. And I think we see that even more as we look at the container ecosystem, as we look at NFV, as we look at networking. Like, there's so much new technology that just getting one engineer or one individual person to have understanding of that rate of change, of what's going on in that ecosystem, it's incredibly difficult. And so we realized very early on that we wanted to be part of a broader ecosystem that we could contribute our lessons and our learnings back to, but benefit from that ecosystem as well. And so that, for us, was the OpenStack decision. We chose to take OpenStack as a technology and build a private cloud as a service offering using that software, be part of that broader ecosystem, and from that benefit from what the entire world was doing. And I think if you look at the broader hyperscale providers, that's a trend, particularly this open by design theory. Like, you look at Google with its TensorFlow technology. Like, these technologies are being open sourced and are building developer ecosystems around them at a pace or a rate never seen before, particularly like Kubernetes is another great example. So the second big thing I think we can learn from these hyperscale providers is figuring out what the business you want to be in actually is. If you're trying to deliver that solution to your end customer, do you care about what the underlying infrastructure is? Or is there a better place to invest your time? And the whole notion of public clouds, I think, is really focused on this notion. If what you're building and the technology you're working on allows you to put your application elsewhere, and you can focus solely on that application, you don't have to focus on the hardware on the OpenStack piece, et cetera, you've just eliminated a giant portion of that stack, of that challenge, from your day-to-day operation. And I think OpenStack is an incredibly unique technology because it, A, gives you the power to own that full stack, or B, allows you to go work with a vendor that manages a bunch of that for you. Or depending on your application, you can do both. So we have customers, for example, that have on-premises OpenStack installation using software distributions, and then buy Bluebox environments powered by SoftLayer that are fully managed. And they use one for particular workloads, and they use the other for other workloads. And because it's all running OpenStack, you get this compatibility layer. You get this common API that works from site to site. And it really allows you to figure out where you're going to spend your time. So I think it's a really important question. The cloud engineering issue that was in the previous presentation is a great example of this. There aren't a ready supply of people who are deeply familiar with OpenStack and who can take that technology out of the gate and run with it in the market today. And that's changing, and I think the Foundation is doing a great job with training programs and with certification programs, but it's still, like, there will never be this ready supply of engineers. And so figuring out where you can spend your time working on or with OpenStack, or working with OpenStack instead of on OpenStack, I think is an excellent question. And so with that, you sort of pick your poison. How are you going to approach this OpenStack problem? And so you can take the open source technology straight out of the repositories and go do it yourself. That's one methodology. You can certainly go buy a software distribution like Red Hat or Mirantis or VIO and use that at a gate. Or you can use this notion of private cloud as a service. And I think we've seen a rise in this type of implementation over the last 3 years with companies like Bluebox, with Platform 9, with MetaCloud or now Metapod from Cisco. But you've got this spectrum of capability on how you can consume it. And I think the interesting thing, particularly from the Bluebox perspective, like we take all of our open source, our OpenStack open source bits, and they're published on GitHub. So anybody can go today and take the same OpenStack that we run for all of our customers and use that. We don't think the value that we're providing is in any kind of proprietary magic in the OpenStack piece. The value we're providing is in that operational knowledge. Like how do you run hundreds or thousands of these OpenStack environments consistently and reliably? And so that spectrum, I think, is incredibly important, and it goes back to what business do you want to actually be in. Another lesson here I think we can learn from the hyperscale providers is around consistency. And so when we launched our local product, so we have a hosted product that runs in SoftLayer, and we have a local product that runs in customers' data centers, we made a conscious decision to limit the hardware profile that that infrastructure will run on to a very specific bill of materials. And the reason we did that is because at the end of the day, for Bluebox, we're delivering a service. And the customer expects an SLA, they expect an experience, they expect uptime. And so for us, ensuring that we've got a single set of hardware, a single networking configuration, allows us to ensure that every OpenStack upgrade that we test in our lab will go the exact same way in the customer's data center. And it makes our lives as operators much, much easier. And we always get the question, hey, we've got all this old hardware that we've got sitting in our data center, and we want to go use that for our OpenStack implementation. Can you do that? And while we could do that, at the end of the day, our goal is to make these environments incredibly resilient. And taking this mishmash of hardware that you've got in your data center today doesn't get you to that end state. Consistency is so key. So starting at that hardware layer, and then you think about the next layer up, the software layer. One of the other things that we've done that we think is particularly unique, and OpenStack is a challenge for this theory, it's around having consistency in each OpenStack implementation that we do. So OpenStack is not it's not a product, as somebody else mentioned today. It's a framework, and as a result, you can implement OpenStack in 1,500 different ways. You can pick different storage backends, different network backends, different configuration flags, and as you do that, your environment starts to become this unique snowflake. And unless you've done all of that configuration through an automation framework, that snowflake becomes incredibly difficult to manage. I think this is one of the challenges with the do-it-yourself approach or the distribution approach, is that every installation from a distribution provider is slightly different. And so as something fails, as it inevitably will, the learnings from that become difficult to reintegrate back into the product. At Bluebox, we stamp every OpenStack installation out using the exact same set of OpenStack code, of OpenStack technology, and so we get this network effect. When something fails, we're able to learn from that failure, reincorporate it back into the installation, and then push that update out to every environment. And so with each installation that we have, the platform becomes more resilient, more reliable, more secure, because we're learning from each individual installation. So, for example, AT&T with the 75 installations, one would hope that they've got those automated so that they can learn from each one of those. So as you get to 75 to 500 to 1,000, like that consistency is so key. And if there's anything you take away from that, I think it's from this talk this morning, it's this consistency message. Stick with one hardware design as close to you can. Stick with one OpenStack installation as close to you can. And you'll end up in a much happier place. Randy Bias at OpenStack Silicon Valley last year talked about this notion of hardware deviation, that you get, even just in slight differences, like a RAID card firmware version, the cards can perform different when you're installing OpenStack. Like it's so frustrating, particularly from your engineering team, to have something work and then to go do it again another time and have it fail because of something as minor as that firmware version. So consistency, I'm just going to keep saying it, consistency is so important. And then the power of automation. We see a lot of folks that we're working with focus on kind of getting their OpenStack environment up and running that first time, and they're doing it by hand. and they get it up and running, and it's great, and they're excited, and they begin to use it, and then the next release of OpenStack comes out 6 months later, and they have no idea how to do that actual upgrade. And we've talked with a lot of customers whose upgrade strategy was to literally stand up another cloud, move everything to it, and then wipe the first one and go back and forth. And like, that's madness. It's just a waste of time. It's a waste of time for these cloud engineers that you're already struggling to find and to bring aboard. And the result, like the reason that occurs is because that automation process wasn't thought of from day one. So there, for example, there was a distribution vendor in the market who, up until about a year ago, didn't actually have an upgrade process for their product. From day one, you need to think about what is the life cycle of your environment. How do you install it? How do you upgrade it? How do you monitor it? And you do that with automation. And it doesn't matter which automation framework you pick, whether it's Puppet or Chef or Ansible, has no bearing. As long as you've got a process and you stick to that process 100%. And you have to do that from day one. You can't begin manually touching and configuring everything and tweaking knobs and flipping levers without this being a primary tenet of what you're doing, or it will come back, and it will come back and bite you. So I mentioned the network effect earlier, but it's a fascinating lesson for me, because if you follow the power of automation, if you follow the consistency concept, you get this really powerful capability. And the OpenStack community, I think, in general, we get this to some extent just because of the nature of open source and with all of the installations that exist in the wild. We struggle a little bit because of each installation is unique, but as an entrepreneur, like when you go and you talk to investors, one of the messages they always say is like, what's your value proposition? How are you going to grow your installation? And they love this notion of a network effect. So the concept here is that with every new user or with every new installation, that the product or the service becomes more valuable. And making sure that you have that ability makes your company more valuable. And so following that consistency message, following that automation message, you have the ability to learn and to make the platform more resilient. And so one of the questions we often get is, hey, can we actually learn, can we take the lessons of these hyperscale providers and use them in our own data center world? And like, no, you'll never actually operate your own infrastructure at the same scale that these hyperscale providers will. But you can take the concepts, you can take the theories and implement them in your daily life as an enterprise provider. And if you start from day one with those tenets, you can be incredibly successful. And it's so exciting to see over the last couple of years the rise of these OpenStack success stories. Like, I think backing up 2 or 3 years to the Portland Summit, like the challenge from all the journalists was, hey, where are these customer stories? Who's using this technology? And now we've got at every summit this endless list of folks that are doing really cool stuff with OpenStack. So I guess my message is OpenStack is a fantastic technology platform. It's a great decision to adopt it, and I'm glad you're all here. You can be incredibly successful with it. Just learn from those hyperscale providers. Take those lessons to heart when you start your implementation, and you can be successful as well. So thanks for having me here. Excited to be exploring the country this week, and appreciate the invite.